Hi, and welcome to this episode of Python Bits. Today we'll talk about something that will confuse many people when they're starting out with Python, and that is mutable and immutable variables. So let's check it out. So what is this thing with mutable and immutable? Well, something that is mutable, what it means is that it is something that can change over time. And immutable is the opposite, something that once it has a value cannot change. So the data types in Python, some of them are mutable and some others are immutable. So that means that if a data type is immutable, once it has, or a variable of that data type has a value, it cannot change. An example of these data types are, for example, integer, float, strings, and so on. Now you say, wait a second, I can change an integer. Let's say I have a variable called x and I assign a value to it, let's say 10. Then I can increase this value by 1 if I want to, or I could give it a totally new value. So obviously I can change an integer. Well, let's dig into some code and see that actually you can't, and we will see what happens. And we will also see why you get the impression that you can change something that is immutable. So first, let's start out looking at something simple. Let's have a string called name, and I will give it a value of John, like this. Now, what will happen if I pass this string to a function? So I have a function here called myStirFunc, and I'm accepting an argument. It happens to have the same name here, but actually it doesn't really matter. This could be anything. And if I just print it here, we will see that it works. So we'll call this function and pass in name, like this. So I get John. The question is, are these two the same variable? Is this the same John, or is this John copied into this one? So there are a number of ways we can find this out, but one way would be to print the ID of name. And the ID is actually the address in memory where the data is stored, in this case John. So if this is the same address, then it's obviously pointing to the same thing. So it's the same John here as up here, and it's not a copy of it. So let's print something here. Let's print let's say just write in main, and then we print ID name, like this. So this will print the address where the data for name is stored. And up here in the function, I will do the same thing. I will say in myStirFunc and print the ID of name. So let's execute this program and see what happens. So as you can see now, in main we have this address, and in the function we have this address. And as you can see, it's the same address. So actually this name and this name actually points out the same area in memory where this name John is stored. So what happens up here if I change the name? So let's change it. I can do it here actually. So say name equals Anna. And then after we do that, copy this and print it again. And let's see what happens. So we execute this, and as you can see now, down in the main function here, we get this address. And then we call the function, passing in John as the name, and we print the ID. And as you can see, we print the same ID. So they're still pointing out the same thing. But then we give name a new value here. And as you can see down here, all of a sudden name is pointing out to a different address. So now this name here points out this address containing Anna instead. So the question is, what happened to this name down here in main now that we changed name up there? So print name, and if we run this, we see that, well, it still points out to John. So what happened up here is something interesting, because as a string is immutable, we cannot change it. Then what happens here is when I do this, this will actually become a new variable. So the old variable name here that points out John is gone. But we still have it down here. So the name in main still intact, is still down there. But the name up here was deleted and replaced with another variable with the same name, pointing out Anna. So this is what happens when we use immutable variables. So let's look at another example. Let's look at what happens if we use something that is mutable, something that we can change. And for example, this can be a list. Lists are mutable, so lists can change. So let's create a list, and I call it value1, and I will give it, this is a list with only one item in it, a string called John. And on the next line here, I will create a second variable called value2 and set it to value1. And then I will change value2. Remember, lists are mutable, so they can change. So value2 plus equals another list containing another name, Sarah, like this. So let's print value2 and see what happens. And as you can see, value2 now contains both the name, both John and Sarah. But the question is, what happened to value1? So we print it, and as you can see, that too contains the same information. So what happened here? What is going on? Why is value1 changing when I'm changing value2? To illustrate this, we will copy the code we have here and switch over to this really neat tool, Python Tutor, their visualizer. So I will paste in the code here and delete all the space we have here. So it's the same code we had, and we will run it and visualize it and see what happens. So as you can see now, we will execute this first line of code where we create the first list, or the value1 variable pointing out this list containing John. So that's fine. Now we're creating the second variable, value2 here, and assign whatever value1 has to it. So let's see what happens. And as you can see now, both value1 and value2 will actually point out the same list here. So it's the same list, it's not a copy of it. We didn't copy the list, we just gave it the same value. So it points out the same value. So now when I add Sarah to it, as you can see, Sarah is added here, and both value1 and value2 points to this list containing both the names. So when I print it, both of them will print these two values. So as you can see, first we print John and Sarah, and then we print John and Sarah again. It's the same list. So this is what happens when we play around with mutable data types like a list. And mutable data types can also do something else that we need to be aware about. So let's see what happens if we have a function that accepts two values. So call it myfunc, and it will accept a value and something I call a target. And this target will actually have a default value of an empty list like this. So what this means, if I call this with only a value, we will create an empty list. And what I will do inside here is that I will take the target and call the append function on that and add the value. And then I will return target like that. So the idea here is that if I pass in a list, an already existing list to this, and I want to append a value to it, it will take that list and append a value to it. If I don't pass in anything for this, it will create a new list for me, append this value to it, and return back that list. So let's delete what we have down here and see what happens. So let me call this inside the print function just to see what happens. So let's call this my func, and let's just pass in a single value here. So we don't pass in anything for target. So what will happen here is that we get a new list and it contains the value of 3 just as we wanted. But the question now is, what happens if we do this one more time? So let's call this with another value, and I'm expecting now to get a new list again, a new empty list, because I'm not passing in anything for target. So it should create an empty list for me and add the value 4 to it. But as you can see, this is not what happens. The 3 that we added before here is already there. So how come? Why didn't we get a new fresh list the second time we called this? The answer is, again, this is a list, this is mutable. So what happened here is that when Python passed by this function definition up here, when we started the program, it saw this function. So, okay, here's a function called myfunc. I will remember that. And I see that it takes 2 arguments. The first one is just a normal, what is called a positional argument. But the second one here has a default value. So I will remember that. So it remembers that we have a second argument called target that has a default value of an empty list. So it is created not when we call the function, but when the function is defined, and that is when Python passes by this line of code. Then Python will skip the rest of the function. It will not execute it until the function is called. And eventually we will call the function here. So we call my function, we don't pass anything for this target, so it will remember that, okay, I have an empty list. So I will use that empty list and I will append this value to this empty list. The second time we call it, it still has the same list, just as when we appended the names. It's the same list. It points out the same list in memory, and the 3 is already there. So that is why we find the 3 here the second time we call it, even though we expect to get a new empty list with a value 4. So we should be aware that it's not a good idea to have something of a mutable type with a default value like this. So we could solve this problem by giving it something else like none. And what we can do inside the function now instead is to check if target is none. So if not, target. And we can write it like that because if something has the value of none, it will be evaluated to false. So this will be false if it is none. If it is a list there, or something else, actually, anything in there, this will be true, so we'll not go into this if statement. So what we can do in here is to assign an empty list to it, and then we append a value to that. So now, if we execute the program, you can see that now we get the behavior we want. It creates an empty list both times when we call this, because now it remembers that the default value is none, and it will use that both times we call it. So that was a little insight into mutable and immutable data types. So you need to be aware of them and take care when you use them. So even though Python is a dynamically typed language, we really need to be aware of what data types different variables has to avoid problems like this when we write our programs. So that was all for today. So see you again in the next Python bits. Bye.